In this video, we'll describe different electrics and rubbers and how they interact. Here we have a hygrometer to measure the humidity, which is essential when experimenting with static. It's showing 45% humidity. We have 3 different electroscopes: bits of paper, a pith ball electroscope, and a gold leaf electroscope. We also have a range of materials and a range of rubbers that we'll be experimenting with. To start, at this humidity we shouldn't have much trouble charging things. Taking this sulfur globe and rubbing it for a few seconds with a wool rag, and already we have some strong attraction. The bits of paper are picked up as well. Let's do the same thing with my bare hand. This is how Gallagher described it. But we get nothing, no response at all. Let's take an old t-shirt next, rubbing the sulfur globe. And it does not have a strong impact, but there is some electrification that results. Finally, we have some tanned deer skin with the fur on. Testing this out, we have nice, strong attraction, almost as strong or as strong as the wool. So those are the sulfur globe experiments. Similarly electrifiable materials are plastics, like this rod I found. Rubbing with wool, it attracts. It picks up paper, and it causes deflection in the gold leaf electroscope. Ebony with wool performs much the same as the others. Now, one of the most common materials used in electrical experiments is glass. I have 2 different glass rods, as well as a wine bottle that I just pulled the label off and dried out. The usual rubbing material for glass is silk, not wool. If I take the silk, hold it in my hand, and rub the glass, then there's only very weak attraction, if any at all. But if I instead take a piece of leather and put the silk on top of it so the silk is not on my hand, then rubbing it, the attraction becomes very strong. Just the kind of strong attraction we would hope for. Let's try it again. If I rub it with my hand, the electric effect is gone. If I wad up the silk a bit and rub again, holding lightly so that it doesn't quite squeak against the glass, then again the attraction is very faint. But with the leather, even a few shakes is enough to get fairly strong attraction. The other glass stir rod, probably borosilicate or soda lime glass, also requires rubbing with the leather pad. And then it works very well. Trying the glass against a t-shirt, and we get minimal electrification. If we dip the glass stir rod in a bit of cooking oil, and I rub a little bit of the oil on my hands to displace as much moisture as we can, let's see if the electrification is improved. If I hold the silk in my bare hand and briskly rub against the stir rod for about 30 seconds, even still, there is no effect. And yet, when I put it back on the leather and rub it, the attraction is quite strong. Finally, if I take a hand drill and insert the stir rod, and I hold the silk in the leather and power the drill, even for quite a while, the attraction is not as strong as we would hope. In fact, it seems weaker than what we could do without it. The next experiment uses a wine bottle. If we take the silk cloth and the leather pad and rub it thoroughly, we see that there is no electrification to be found on the wine bottle. I wouldn't think the type of glass is the problem, though glasses with high alkali content are known to be less effective. I also tried this with a clear bottle, which had been sitting next to our wood-burning stove for a couple days to make sure it was thoroughly dried, but I still couldn't get it electrified in the slightest. I hope to have shown what common enough materials can be used to recreate electrostatic experiments, because it's hard to find useful information on getting it to work properly. In summary, I would say that for good results, keep your electric and the rubber as dry as possible. It is essential to monitor humidity to verify that the air is sufficiently dry. Storing materials in an even mildly humid environment can make the difference between an experiment working and seeing no effect. Hair dryers and space heaters with fans make great tools for drying up an area before beginning experiments, but it takes quite a while before things become sufficiently dry, and the moisture will return quickly once the hot air is turned off. If you have a glass bottle or tube or bowl, it's essential to verify that the inside is as dry as the outside, otherwise the glass will appear to be unelectrifiable. Consider baking materials in an oven prior to experiments to verify that they are sufficiently dry. I'll have a page with notes about these experiments on my website, including links and citations to contemporary accounts from the 17th and 18th centuries that should help answer more specific questions.